first, Assalamu alaikum wa rahmatullahi wa barakatuh. Bismillah ar-Rahman ar-Rahim wa salatu wa salam ala Sayyidina Rasulillah. First, I would like to thank GSMA for inviting us to this wonderful event. I believe that the collaboration between different industries is something very crucial here in Egypt and in the world. And I would like also to take the opportunity to thank Dr. Amr for his starting presentation. I was struggling of how to start or where to start point, but Dr. Amr actually, as we learn from him a lot always, had pointed out on a very important part. When the technology should be adopted, when it should be introduced, where we can get the benefits. We all know the S-curve. So the S-curve of the technology is very important. When it comes to a certain peak and then start to reduce, then you need additional technology to come over. And this is, if you go to the slides, please, yeah. So, and this comes with the Eutelsat group way of doing things. So Eutelsat, as maybe all of you know, is very famous in the broadcasting GSO field, was used to work for more than 40 years in the industry, had developed a lot in the broadcasting. Yes, next slide, please. Yes. The mission of the Eutelsat group is to connect the world using the infrastructure of the satellites. Now, coming to the point that, or a projection to the point was Dr. Amr mentioning, in 2023, a merging happened between Eutelsat and OneWeb, forming a new Eutelsat group, which is operate in both infrastructures of the satellites, in the GSO and the non-GSO. And this continuate our S-curve of innovation, of having the benefits of the both networks. We never say that there isn't a technology better than the other, or there isn't a network better than the other. It is very important and crucial to take the benefits from these technologies, depending on the use case that I would like to do or to adopt in the country. Here comes the regulatory function, which is very crucial and function, when to adopt that. So as a Eutelsat group had merged with OneWeb using the traditional GSO system, which is still in operation and will continue to operate, and now going to a new technology, which is in the LEO orbit, to operate the Eutelsat OneWeb. Next slide, please. With these both infrastructures, we create a connectivity to the globe in which we are able to have a full 24/7 coverage pole to pole using the GEO and non-GEO networks in order to deliver our customer reliable services all over the time. Based on that, it opens and unlocks a lot of applications that was not able to be done. So for example, the GSO is very useful for us to have the services in a prime way, in a reduced cost. In the non-GSO system, it comes with low latency and unlock additional applications. If you go to the next slide, yes. So based on that, we have mixed between the both benefits of the networks in the GEO orbit and the LEO orbit. As an operator of both technologies, we can simply say that there is no technology prevail over the other. Each technology has its own advantage, has its own challenges, and has its own benefits as well. And when to decide or where to decide to adopt it is based on the regulations and based on the consumer needs, whom are the focal point of all of what the regulator is doing along with the different operators. Next slide, please. So I bring you some connectivity solutions. So here we would like to emphasize something very important about the strategy of the Eutelsat OneWeb. So Eutelsat OneWeb is not about internet connectivity. It is about connectivity solution. There isn't a complete difference between both, and this is a myth happening now in the market because of that. So the Eutelsat OneWeb is offering a connectivity services, not an internet services, and there isn't a big difference between both. We offer the channel for the operator to provide his services depending on the use case he wish. Next slide, please. And by having different infrastructure, hardware plans, it opens a lot of applications that was not able to be happening in the previous days. In this connectivity types, we have mobility, fixed, land, and sea and air. All of these type of applications is now available using a ubiquitous user terminals that was not available by the GSO system and now available by the non-GSO systems. And this comes us to a very important point we would like also to deliver as a key message of today's meeting. Working alone is not something possible. You need the mix of the technology. Next slide, please. You need the mix of the you need the mix of the technologies in order to respond to the consumer. So the Eutelsat OneWeb employed a strategy of not reaching out to the consumer directly. It always relies on distribution partners and partnership with the incumbent operators in order to extend their coverage. We have a lot of success stories happened. So we have a lot of cooperation with mobile operators and looking forward into more and deep discussions with them. Currently, we are operating with Airtel in more than 14 countries in Africa. With Orange, we are also planning some operations. We are operating with them in France and extending the services in other countries that they locate in. With Vodafone as well, we have a lot of cooperations in place. And this all comes with two important key factors. The high level of innovation of the network infrastructure used. And second part is the openness. So in the Eutelsat OneWeb system, we are not offering a Pandora box for you in order to have the services. Even the user terminal being used is manufactured by different vendors. We are not offering you the user terminal that you are going to use. There are a lot of companies is doing that. We are cooperating with those. You will see Kaimeta, Inister, Intellian, many of the vendors whom are manufacturing the user terminals to be developed. By this, we actually imply an open system for the whole to use and to extend the current affordability of the services of their own to the operators incumbent in the country. With that, I conclude my presentation and thank you for your time.
Thank you very much, Amr. I don't know about you, but I didn't, on his first slide, the guy that was on that picture and the guy that we had on stage, I don't think they're the same person. He might claim it's the same, but there was a lot more hair on the first slide. So thank you very much for sharing those insights. I think we'll talk a lot more about some of the points that you have made in your presentation, Amr. And with that, I would like to invite Ahmed Tawfik to the stage as well to give us some thoughts around how to regulate going into the future.
السلام عليكم. أنا اسمي أحمد توفيق. I'm part of Nokia. I'm the head of technology, so I'm leading the technology team in Nokia, and I'm based in Dubai. I'm very happy to be here. I'd like to thank GSMA for inviting me to be participating in this panel. And also, it's an honor to be sharing the panel with Dr. Badawi and also Mr. Amr here on my left side. So I'm going to be bringing a different angle to the discussion here for this panel. So I'll be talking more about 6G. I know it's a little bit surprising because Egypt just signed, or they just licensed 5G in the past few weeks, but actually the world right now is actually moving towards 6G, right? So we'll talking about how we shape the 6G future from vision to action. And one disclaimer, I know that it's very late. I know a lot of you are tired, so I'll do my best to keep this short and keep it interesting. All right. Okay, so the question is, what are the push and pull trends for 6G? So why is 6G needed? To understand that, we need to understand first what are the trends and challenges, right? So if you look on the left-hand side, you're going to see that some of the trends and challenges, we have three main trends and challenges that are driving 6G. The first one is the demand for higher network performance. What does that mean? 5G today, in the countries that adopted 5G back in 2020 and 2019, it's hitting its capacity limits. So meaning that they're running out of capacity on 5G, and it's not enough anymore. So all the algorithms and techniques that are being used, it's not using the spectrum efficiently enough to address all the capacity demands that we're seeing on 5G. So, and I think you all know that, you know, the traffic is growing year over year. We have a 30% or maybe 20 to 25% increase in traffic year over year, right? So users are hungry for more traffic and they need more and more capacity. So that's the first one. The second is if you look at the ecosystem of devices, it's vastly increasing with time, right? So if you look back 5 years ago, it was mainly mobile handsets, maybe some CPEs, and maybe some wearables like smartwatches, right? But if you look today, it's expanding a lot more than that. You have drones, you have robots, you have more wearables, you have the smart glasses. There's a lot going on, a lot of more devices that cannot natively connect to 5G, and this is something that 6G will be taking into account. And then the final thing is I think that, this has been the buzzword in the industry, telecom industry, IT industry in the past 2 years, AI, right? So AI is going to be generating a lot of traffic. And not just a lot of traffic, but a lot of use cases as well. So that's going to be driving what 6G is going to be designed for. And on top of that, there's also the API economy. API, for those who are not familiar, this is how two software systems talk with each other using an API interface. So the telecom industry was a very closed industry, right? Nobody was allowed to talk to the network in any way. This was all under control of the operators. What is happening right now, and we've seen examples of this in the USA with TMO US, what they've been doing is that they've been exposing the network to third-party software developers. What they do is that they can request on demand for a slice of the network so that they can use it for a particular purpose, right? So that's also driving it. So now the operators are realizing this can be a new revenue stream. Maybe to bring that idea closer to you, I'll give you an example. So let's say that you're at a stadium during the halftime. People go to the food venues, they go to the shops, they want to buy jerseys, they want to buy lunch, they want to buy drinks and so on. The problem is that the MasterCard and the Visa machines, they're shared, so they're using the network, the same network that is being used by the mobile users, right? So now everybody's competing for data. So the problem is that now these machines cannot connect to the network, they're not able to sell any food, any merchandise, any jerseys, nothing at all. So what happens here is that on demand, you can allow, with this API, you can allow to create a slice to be used just by that Visa and MasterCard machine so that they can get all of these payments gone through the system, right? So, and you don't need that slice to be created permanently. You can just create it for 30 minutes, which is the halftime, and then after that you delete that slice. So this is going to generate a lot of new revenue streams for operators by exposing their networks to third-party software developers. Right, so if these are the trends and challenges, how can 6G address them? So there's two fronts where 6G can address them. If you look at the top half, so revenue and business growth, how's that going to happen? Well, first off, you need to make sure that you can natively support all of these devices that are popping up, right? Whether it's drones, robots, smart wearables, anything like that. You need to make sure that they can natively connect to the 6G network. Second is that you also natively allow this API exposure. So our networks today are not built to allow the network to be exposed via API to third-party software developers. This is all proof of concept. In the US, yes, they managed to do it, but there's still a lot of challenges, a lot of things that need to be taken into account. Third is NTN. So I think, with NTN, this is basically a satellite sending out it's acting like a radio. So satellite is offering coverage in rural areas where you're not able to build base station sites, right? And then there's sensing. And sensing, this is something completely new. And think of it as the base station acting like a radar, right? So acting like a radar, it's sending out these signals, it's receiving back the signals because it's trying to sense the environment. And when it senses the environment, then it can start taking conscious decisions about what to do. One of the applications for the sensing can be driveless vehicles, right? Exactly. Yeah, autonomous vehicles, yes, thank you. Exactly. So autonomous vehicles meaning that you need to sense the whole environment so that you can direct the car, take decisions, and so on. Yes, it's being done right now, Tesla has it, but it's not using the mobile network for that. With this sensing, it's going to be a lot more accurate and a lot more safer, right? So these are some of this is how 5G is going to address it from the revenue and the business growth. Now on the bottom half, there's also the performance leap and this extreme cost efficiency. So first off, you want to make sure that you design the radios to be green by design, right? So green by design meaning power efficient. You want to make sure that it's not consuming too much power. And one of the targets of 6G is that they want to offer 10 times more traffic at 50% the power consumption on 5G, right? Another thing is extreme automation. So right now, I think everything is moving in the direction of automating everything. You want to limit the human involvement in decisions. You want to make sure that everything gets automated by just giving it some business decisions of what needs to be accomplished. And then finally, you want to make sure that it's a single and it's a simple architecture, right? With a single and simple architecture that you can easily upgrade 5G to 6G, right? And of course, all of that to happen, which is going to bring it together. First off, if you look at the green in the middle, you need spectrum, right? So that spectrum is required. And then on top of that, you also need computational power for that. So the existing computational power of the hardware equipment in the networks is not going to be enough, because if you think of it, there's a lot of data flying back and forth. There's a lot of information being transmitted. And this is going to require a lot more computational power in the equipment that are in the mobile networks. So to sum it all up, the design principles for 6G is that they want to be sustainable. Like I said, 10 times the traffic at 50% the power consumption of 5G. You want to be resilient and secure, because again, with all this data going around, you need to make sure that you have the right data privacy policies and security policies in place. And then finally, digital inclusion, meaning that you want to make sure that now the network becomes accessible to everyone and affordable for everyone. All right, so if I move on to the next slide. So this is, again, giving you a glimpse of what is going to come with 6G, right? So you have the physical world, you have the digital world, and then you have the human world. What 6G is going to do is that it's going to be connecting all of this together. Meaning that first off, how do you transfer the physical world to the digital world? So this is basically what they call digital twin. So, right. So you're trying to make sure that you transfer everything in the physical world, you make it available in the digital world. But at the same time, you also want to connect the human to that. So how are you going to connect the human to that? It's by human augmentation. So we call it extended reality. So you've seen these glasses where people are wearing, where you're able to access this digital world that is already connected to the physical world. An example of that is you can go to a shopping mall without actually being there. And you can walk into a shop, you can see all the clothes, you can try them on. All of that is going to be possible with this, by connecting all three worlds together, the physical, the digital, and the human. So this is just a glimpse of what 6G is going to be able to offer. Metaverse was something that was going into that direction, but it came a little bit earlier. The networks were not designed, we're not ready for that, but it's going to eventually happen, right? So Metaverse is happening soon, and it will be enabled by 6G. All right, so how are we paving the way for this? So I think most of you know that WRC was held in Dubai in December of last year, where they were discussing the spectrum. So this is what you see on the left-hand side is the spectrum cake, right? And what what they had agreed to is that they've defined a new mid-band from the 6.4 gigahertz to the 7.1 gigahertz. This can be an extension for the 5G mid-band, and it's also can be used for 6G as well, right? And like I said, you need computational power and you need spectrum. So spectrum was already identified last year. Part of it was identified. What you can see in the white, so the 550 megahertz and the 1275 megahertz between the 7 and 15 gigahertz, that's going to be a discussion topic for WRC 2027, right? And on top of that, you have an additional 400 megahertz between the 4.4 and the 4.8. So they've already identified something today, and then they have the extension of the bands that are going to be available. That's going to be discussed in WRC 2027. Right, and this is just showing the roadmap. So if you take a look at the 6.4 to the 7.1, you're going to see that all the countries in orange, pink, blue have already agreed to allocate the 6.4 to the 7.1. Right? So this is already agreed to. It's going to be allocated for mobile services. For the rest, you can see for the US, they haven't agreed to that. So the US are looking at a different spectrum. Same thing for Asia. Right? But this is just showing that it's already possible for the region. GCC countries, by the way, have already allocated. So just 1 year after this WRC identification of the 6.4 to the 7.1, GCC already, so UAE, they just announced that, I think, last week, that they've assigned this, and they're splitting it half and half between Du and EITESAL. Right? And then to my last slide before I hand back to Kamal. So, So the 6G success, it depends on a unified approach. So all three entities need to come hand in hand. The standardization, the regulatory, and then the parties that are innovating, right? So none of them can run alone. They all need to work hand in hand, and they all need to be aligned and harmonized. So you can see this is pretty much the roadmap of what we have. If you look at in the regulatory stream, you can see that WRC has already agreed with the regulators that we have some spectrum in 2023. The rest is going to come in 2027. And then on top of that, you can see the standardization is already working. So they've already identified that release 21 is going to be the release where 6G will be launched. So that means that we're talking about 2029, 2030 is when we're going to have our first 6G commercial launch, right? And then on top of that, you have these innovators in the first stream at the top that have to work on testing out these new concepts, these new algorithms and all that to try and build some white papers that can be used by the telecom industry once 6G becomes commercial. All right, so sorry for taking too much time. That's all I had, so thank you, and Kamal, back to you.
Thank you very much. Apologies for the ungraceful climbing up on the stage. But it's very interesting how in the same conversation, in the same room, on the same day, we can be talking about keeping 2G networks on so that we can get people with feature phones connected. But then we can also be having, in the same conversation, discussions around 6G and how to use artificial intelligence to basically create magic in our digital economies. So thank you very much to all of our speakers. I'm sure you will have some questions, particularly related to the last set of slides. I might address some of those questions through the discussion that we'll have with the panel, but please be prepared to have your questions as well ready so that the panelists can have answers for you. But without further ado, I will start off this panel discussion with coming to Dr. Badawi, because we're talking here now about a lot of technology that is coming, especially as we've seen from Ahmed's presentation and bits of what Amar also presented. You've had significant experience in developing regulation and enabling a lot of the digital progress that we have seen in Egypt so far. So reflecting on your time in the seven odd years that you were president, and also on your time as a board member at the NTRA, what do you reckon were the key regulatory strategies or initiatives that were the most effective in helping to foster innovation in mobile technologies, and also what lessons do you think other regulators can learn from your experience? Because there are actually regulators from quite a number of African countries as well in the room who can learn from your experience.
Thank you, Kamal, for the question. It's a very important one. Well, during my tenure, the NTRA was a member in several regional and organizations or associations where we had the EuroMed group, Arab Regulatory Network group, and the ATU. And in these, we had a yearly meeting where we, in some cases, developed projects with other countries to handle new technologies. Also, these associations open the door, open channels between our experts and their experts to make use of the experiences and do knowledge transformation between these countries. So that was one strategy we were working on, is that we did not, we believe that we don't have reinvent the wheel. Let's make sure that we help each other and benefit from other people's experience. The other one, which I believe was quite effective, is that we looked at our relationship with the operators as a partnership operation, as a partnership. And as such, we used to talk to the operators get their input while developing the regulatory policy or strategies. So I think these are two examples. And of course, the main thing is that we make sure that our experts, our people were very properly trained and were properly informed about any new technologies or any regulations that we needed to form. So that's the basic thing for us to be able to decide the right strategy. And I believe that's all what I can say here. I don't want to take much of your time.
Thank you very much, Badawi. I think that's very interesting, particularly the point you noted about knowledge sharing and not reinventing the wheel. We've seen some of the work that the NTRA is doing today in terms of creating an environment where African countries can come to Cairo and Egypt and participate in knowledge sharing sessions. So that indeed is something that can help the region move forward together. I'd like to come to Ahmed next, and I mean, you painted a very good picture in terms of what the potential future looks like when it comes to technology. I wanted to know from your side, what do you reckon are some of the most progressive spectrum policies that can play the most important role in enabling some of these emerging technologies, particularly from how mobile operators can basically deploy these technologies?
Thank you for the question. So I think that the regulators, they play a huge role in easing the rollout of new technologies for operators, right? And I think that it's also important that the regulators, they keep an open mind when trying to define those policies. We need to keep a progressive mind to understand the different changes and dynamics in the market. And I can give some examples. One of the good examples that helped a lot was making the spectrum technology agnostic, right? So meaning that you allow So one of the things is that they can help the operators by making sure, one of the policies that worked was making the spectrum technology agnostic, right? So meaning that you can use it for any technology. You want to refarm it from 2G to 3G, you can do that, 3G to 4G, 4G to 5G, so giving them that kind of flexibility. And I think it's become an industry standard. But now we also need to think beyond that. So one of the things, for example, is that we have, when the spectrum is scarce, so there's not enough spectrum to give to all the operators, you need to think about some network sharing policies, right? So allowing the spectrum to be shared between different operators, and they have an agreement of what is the sharing ratio. It can be 60% to 40%, can be 50 to 50. So, and that will depend on the traffic patterns that they have on each of their sites. That's one thing. Another thing that they need to really take really good care of is that one of the things that is emerging right now is the enterprise business. And I think it's regulators' responsibility to enable and make it a success, and also the concept of a neutral host. So I'm not sure if everybody's familiar with the concept of the neutral host, but the neutral host, one of the countries where this has been explored extensively was Saudi Arabia. So in Saudi, we know in the Haram area, in the Medina area, all those areas, there's very limited space, and it's very much an indoor culture. So you need to make sure that you want to make sure that you have coverage indoors, but there's not enough space for each of the operators to bring in their own equipment. So what happens is that they say, okay, we want a neutral host, meaning that one equipment is going to be transmitted to all of the operators. So you also need to put in policies forward that is going to help these neutral hosts enable them and be able to do that. Now when we come to the enterprise, the challenge that the enterprise customers are facing is that they don't have their own spectrum, right? So anytime that they want to build a private wireless network, they have to go through an operator. So one of the things that regulators are considering is a concept called light licensing. And this has, by the way, in the latest auction in Saudi Arabia, they defined the 4 to 4.2 gigahertz for light licensing. What does that mean? It means that when an enterprise acquires this license, they can acquire it in a certain area, right? It's not across the whole country, just in a certain area, because he only needs it in that area. So with this light licensing, you're really enabling, whether it's a neutral host, whether it's an enterprise, you're allowing all of these newcomers into the business, you're allowing them to be able to
So these are all different. This has not been available in the past, but today, with the limited spectrum, with these newcomers and new proposals of enterprise coming in, I think the regulator can play a huge role in enabling all of these new players to be able to enter in this market, which is predominantly occupied by the big CSPs or the big operators that are controlling this market.
Thank you very much, Ahmed. I think that painted a relatively good picture as well of the future. How some of the things we're doing today will have an impact on that future. Infrastructure sharing, like you mentioned, I think that's going to be playing a very important role going forward. And it will be interesting to hear from Ahmed's perspective as well. There's been a lot of discussion around innovation, and I think one of the things that satellite services are traditionally known for is broadcasting, which you touched upon a little bit earlier on. But I know that there's a lot of innovation as well that is happening in that space. So, I mean, from your perspective, you know, when you're looking at the innovations that Eutelsat is exploring in terms of how to improve the capacity and efficiency of satellite communications, how do you foresee these innovations basically impacting the regulatory environment that we have today, and what do you think the future holds in terms of what regulation needs to continue, if possible, for that innovation to continue?
Situation on how to deal with the satellite technology. But we can see actually a lot of dimensions related to how to continue or to pursue the innovations in satellite technology. First, you need the spectrum. Secondly, the harmonization among the countries for the using of the spectrum. And the third part comes as an important pillar on the regulatory aspects, how to license the services in the country, which is very crucial. And then it comes in parallel with the technical advancements of the compatibility between different networks and versions, in which you are not offering the services to the consumers by yourself. You are collaborating with others operators. And this is something very important to do. And we rely on the compatibility and the economical scale of deploying the networks to use it in our networks in the space part, so that we are, for example, using the FTE standards, applying it in the Eutelsat system. So when you are using the Eutelsat system for a case of a cellular backbone, you have the same signal in the protocol. You don't have the problem of the compatibility. Also, when you have a newcomers like direct-to-devices, you have something that needs a compatibility with the current phone that you are using in your phone. So it needs a lot of technological advancements and innovations in this one in order to reach what you need with the end. So there is a lot of things need that. But also there is an important features. Spectrum regulations is a key and crucial ingredient along with the innovation. Not single one can live alone. Thank you.
Thank you very much, Kamal, for those insights. I think one of the things that jumped out to me about what you said is beyond just what we're seeing in terms of harmonization of regulation and harmonization of spectrum, also harmonization in the technology itself is happening. The specifications as well are basically becoming harmonized so that we can enable seamless integration between both sorts of technologies. I have a bunch of other questions to the panels, but I want to believe you might, the audience, have some questions for the panelists. So maybe just before I go into my second round of questions, I want to check, does anybody have questions from the stage, from the audience? Question here in the front? Yes.
Thank you for this great panel. Actually, all the panels were great, but I have a question to my friend here, Ashour. Of course, you mentioned about connectivity. You are working in with your new system with GSMA satellites. My question is how you can manage to have the backhauling or connectivity for 4G or 5G with the delay, especially from GSMA. Because this is very sensitive for the delay, and of course we use of physics, we have some delay for the delay.
Thank you, Jamal, for the question. Actually, this is a very important thing. So, this is why we have moved, or why actually we as the Eutelsat have moved from the GEO to the non-GEO to address this challenge. Originally, the GSO can overcome this challenge, but it comes with a lot of cost and also the limited technology. So you can, for example, use it for the cellular backbone to have a 2G. But if you have it for a 3G, you need an entire transponder to do that on the GSO system.
And also you need to apply a lot of technologies in the compression in order to avoid the latency. And here comes the solution from the non-GSO systems. So you have the non-GSO system that have a lower latency. It comes with a challenge that it is not single satellite, multiple satellite constellation, passing over around the world, and also the Earth itself is rotating. So it comes with a lot of challenges, but it was successful in addressing the lower latency to, for example, the serial backhaul speeds. So we have tested the non-GSO system to provide the backhauling for the 3G, 4G, and now also for the 5G in the laboratory and have improved working. So having this moving from this situation to another situation is using the innovation of the technology. It is not coming without having this investment in the technology to happen. And of course, the regulatory situations or the regulatory clearance and the spectrum availability allows us to perform such work. Also, we are trying to extend the this capacity. So, for example, one of the topics addressed in the next WRC is to have an additional spectrum for the K-band that we are willing to use to extend the spectrum capacity so that you will be able to offer more connectivity services. Usually, when we speak about data services, it's not like the connectivity. Serial backhaul is a bunch of capacity that you need gigas. So, in order to do that, at a certain point, you need also more spectrum. So, it is actually a proliferation of all of these in order to attain the required potential.
Thank you very much. There's another question for Dr. Azouz in the front. Yes. Thank you. This question is mainly for you mentioned in your speech that the terminals are manufactured in or Eutelsat is one manufactured or manufactured by different manufacturer. So who sells this product to the customer? OneWeb or the customer can buy it from any store. And when this equipment becomes available at the customer, who will store it? Because this is really important because the navigation of this test station is very essential for the government if they want to stop some people or something like that. And who is your customer? The government or the enterprise, the government organization, or who? So this is the first part of my intervention. So if you can reply for this first, because you need to observe it. But I think he will apply, he will reply the same for all aspects. Good luck.
Thanks, my mentor, Dr. Azouz, on raising this very important question. This is actually one of the things that Dr. Azouz was working on a long time ago on how to protect the country, nation's sovereignty from the systems. And here also it comes with the innovation. So the non-GSO system is different than the GSO system. The user terminal of the non-GSO system is ubiquitous, having a GPS, and also have a unique identifier and a unique identification. So it has an IMSI in its terminal. So any equipment imported to the country, the IMSI is known, its location is known, it is not activated unless the importer having the account to activate this terminal can activate it. It will not activate by its own. Now, having a different vendors, this means that when we cooperate, for example, with a mobile operator in Egypt, for example, and would like to have directly, he sees that the use case for him is very good with Interior, and he got the good price for Interior for the user terminal. He ordered the user terminal directly from the manufacturer, and the vendor sent him these terminals, which have this IMSI. The regulator can register which IMSIs are in. And then the network operator himself have an portal. This portal activates each IMSI along with. Also in the control of the distribution partner or the mobile operator here in the country, they know where is the location because the tag is part of the GPS coordinates for the IMSI of the user terminal sent to the network and then to the distribution partner or to the service provider. So for example, the mobile operator here or the service provider here in Egypt knows the location of the terminal where it is. To what precise it is very accurate that it is actually needed for our system to operate. So for example, you will not be able to, the satellites are moving, so you need to provide the user terminal, where is the satellites are? He cannot identify himself unless he has a GPS. So if the GPS is not accurate, he will not get a signal. So I must have it very accurate on the system so that he can synchronize with the motions of the satellites. So the location is known, the MC is known, the reporter is known, so you have the full control over the network. So for example, you can say, I have something in Alexandria now, and I want to switch off the terminals in Alexandria. You have the list of the GPS locations in Alexandria, you just pick them out, they are out of services. So, thank you.
Thank you very much. We'll take one more question from here, then we'll go for another question.
A big question, small question. We need to continue. Is it possible?
Sorry, Mutaz, I didn't get it.
I didn't finish.
Oh, you didn't finish?
I asked everything the request I will ask. But I will ask about something very essential for the country. Also, if there is the plan or the strategy of OneWeb or Eutelsat to have direct device communication, or they stop by internet, broadband, and no call, no text, no anything like other operators. What is the situation for OneWeb?
The general strategy on this occasion that we are not offering services to any user in any country. The people understand the country is the people who are working in the country. So we never go to a country and try to provide the services directly to the users. We rely on the operators to do that. So we have to first ensure the integration of the system, the direct device, and then we offer it to the incumbent operators in the country to provide the services.
Yes, thank you very much. We'll take the one more question from there.
My question is for Ahmed Tawfik. Spoke about artificial intelligence in 6G as a source of additional traffic and additional use cases. In fact, 6G is still in the pipeline, and there is hardly any aspect of AI that's not included in the specifications. So, for example, Nokia has a very active research group on transforming the physical layer, where they do, custom modulation constellations, etc., do away with equalizers and stuff like that. So if you go to the user side, the access, the resource allocation, etc. My question is, do you see that the roles of the regulators are going to be changed when most of the network is operated by artificial intelligence algorithm? Perhaps they need to regulate how those algorithms work, what type of data to be collected, etc.?
Okay, it's a very good question. So I'm not sure if everybody's familiar with the AI RAN Alliance. So actually that's a new alliance that has been created when Nokia is one of the founding members of it. And they have three verticals for AI. They have AI on RAN, AI for RAN, and AI and RAN. So the concept is fairly new. So one of them, which is AI for RAN, is typically what you're trying to do is you're trying to get AI to control the algorithms inside the base station, make decisions about handovers, make decisions about resource allocation and stuff like that. Then there's AI on RAN, which means the new AI applications, they want to use the RAN resources. So these AI applications are going to generate traffic. And then there's AI and RAN, meaning that now you're thinking, how can AI and the base station utilize the same resources together and share them together, right? Because now RAN is moving to cloud, AI runs on cloud, so both of them now can start sharing the resources. So this AI RAN Alliance is something that is still new, and they're going to be discussing all of the points that you raised. And one of the things that we know for a fact that AI is going to do is that it is going to create a huge paradigm shift in how these networks are being run. So one of the things, for example, we have smart glasses. And with these smart glasses, the problem is that you cannot put an AI engine in the device, in the glasses. It's not possible. So what happens is that, yes, they can run some AI algorithms by themselves, but eventually they are going to go to cloud and then ask the cloud to run whatever AI service they want, and then it comes back to them, right? So this in itself is generating a lot of traffic. So for that, you need to make sure that you have your networks prepared to be able to take into account all of that kind of traffic that is going to be generated by it. So from a regulatory standpoint, I think one of the things that I said in my presentation is that with AI,
There's now, and with the direction that 6G is going into, which is only going to be enabled by AI, the problem is that there's so much traffic being sent over all the interfaces. And now it's not just user data, it's a lot of information, right? So information about location, information about the size of things, and information about the user of what kind of things is he doing, and so on. So there's so much information that is being sent. And I think that one of the most important things, because you don't want to, the thing is that when the new technology comes out, when AI comes out, 6G comes out, you don't want to slow down the rollout, right? So you need to be prepared. One of the main areas where I think the regulator can prepare for is the data privacy and the security policies. Because I think this is going to be one of the biggest, it already is a big topic on the internet, but now it's coming to the mobile networks. And now the regulators, they need to really be active in that area to control what kind of policies do they want to put forward, so that when AI is ready, when 6G is ready, they're ready to hit the ground running. They don't want to start doing all this activity once AI and 6G is ready, because then that means that you're just going to have to slow down the rollout of AI, the rollout of 6G, exactly. And I can give an example, by the way, the banks. If you think of it, outside of Egypt, everybody had the virtual credit card. But in Egypt, because we were not ready with the right policies, that has been delayed by maybe 5-6 years compared to the rest of the world, right? Because they weren't ready for that. So it's important to be ready, and I think security is one of the most important things where the regulator can play a very effective role in preparing for AI and 6G.
Thank you very much, Ahmed. And I think you make some very important points, which gives me a perfect segue to ask Dr. Badawi my next question. There's times when we deliver workshops on spectrum pricing and auctions in particular, and one of the things that we always advise regulators to do is to think like a mobile operator's CEO when you're making decisions around how to design an auction. So I want to give particularly the private sector, mobile operators, vendors, the opportunity to also think like a regulator. Of all of these innovations that we're talking about, from a regulator's perspective, what do you see as the challenges that you have to overcome to be able to develop regulations and policies that enable these emerging technologies, and how do you think we can overcome them so that we can allow these emerging technologies to develop more rapidly?
Okay. I think the challenges for emerging technologies, first of all, is really the security issues. The security issue is a main challenge to start with, and it has to be resolved. So that's one. The other one is how would be competition issues between the different operators. We don't want, for example, a D2D operator working only with one of the MNOs. Would like to see competition there to provide service to all the people. By the way, there was something I missed in my introductory remarks that I'd like to say that there are two steps that Egypt took in the past 2 weeks regarding the opening of the 500 megahertz in the lower 6 for Wi-Fi or unlicensed services, together with the licensing of Wi-Fi calls. There are two steps that integrate together to help provide better service to Egyptian citizens, especially in very congested areas where the spectrum is very is not enough to provide such service. And I think these services will help improve what the Egyptian citizens are getting. So that's definitely a step in the right direction. And in the same time, it indicates how we can integrate technologies together. So we expect that we're going to have 5G technologies, and of course we can also integrate that with other technologies like maybe D2D, Wi-Fi, to help provide better service for the Egyptian citizen, which is what the regulator should be going for. Direct-to-device technologies are still, in their infancy, where I understand that one company has just emergency services to their devices now, and it's still under development. I think how it's going to be done with the operators is not very clear yet, and it will require cooperation between the satellite operators, the MNOs, and the regulators, of course. So I cannot really say how it's going to be done, but the three parties should be exchanging information as the information is coming out, to make sure that these services will be available as soon as they are ready to be delivered.
Thank you very much. It sounds like regulation is going to continue to be tricky in terms of how it needs to keep pace with this innovation. Sometimes even the technology itself and the consumers find themselves struggling in terms of keeping pace with the uptake. But you did mention D2D a bit in your remarks, and I want to come to Ahmed now, because this is a new area that is. There's a lot of noise basically around the subject of D2D nowadays. We've seen some satellite operators, satellite LEO operators, now deploying services that are providing broadband services directly to consumers. And from what you see, especially in Africa, we don't yet have the right regulatory frameworks in place to license these sorts of services. Countries are going about it as it comes, and they're all doing it differently. So I'd be interested to know, and maybe for guidance for regulators in the room, from your experience being an operator in that space, what have you seen in terms of some of the key components of regulation and licensing in the markets where you have seen satellite broadband services being made available? Your company might have been involved or not, but it will be interesting to know what you can see as common, and what you'd advise and recommend for regulators going forward to put in place as a framework to license satellite services to be able to provide broadband services directly, and D2D services as well.
So actually, even despite that we are not offering services to the end users, we are still in back-to-back agreement with respect to the services offering to the users in the country. So for example, the services of Eutelsat OneWeb services comes with an SLA. This SLA implementation is reported to the regulator so that he can monitor the services being offered is along with this SLA offered or not. But adding to this point, the point clarified by Dr. Amr was very crucial, that you need the collaboration because it is under R&D now, and a lot of discussions and a lot of noise is happening. So you need the cooperations of the industry and the regulators, policymakers, in addressing this challenge, but also you need a very important part in this triangle. You need the vendor of the equipment. The vendor of the equipment is very crucial and very important, because we cannot have it on the devices without having the appropriate standards. And the appropriate standards is delivered by all these entities together. So we think that the driving component in this part mainly will be the standardization process, where how the cell or the device that you have in your hand is compatible with a satellite operating in space. This is something very crucial. Beside the current challenges that have been resolved at this stage of using low Earth orbit, thanks for the technology, afforded us to be able to work on lower altitudes, make us closer to the Earth, make it more less latency to the users, enable many applications. Also, thanks to the technology of having multiple launches within a feasible cost, making the services more affordable. The cost of the network have been reduced so that you are able to deliver such service in an affordable manner. So you still have different components, but you still also have different challenges. So we believe also that in addition to what Dr. Amr said, is the point related to the equipment to be in use. This is very crucial in addressing this technology.
Thank you very much, Amr. I know we're running fast out of time, so I'll ask maybe my panelists for final sets of comments and thoughts to share with us today. And I'll start off maybe with Dr. Badawi, just to share any final comments you might have for the audience to summarize all of the points that you've made today, and also maybe perhaps if there's anything that you think is important for them to be aware of from a future-looking perspective.
Okay, I will be short, and I'll be just repeating what other people have said before, that spectrum is the essence for this industry, and the quicker we get the spectrum in the hands of the operator that are needed to provide good, reliable services to the Egyptian citizen will help development of Egypt. So that's really my message, and that's very, very important. And you've mentioned in one of the things about the challenges. I mean, we're talking 6G. We're still, we're trying to introduce 5G right now. So hopefully we'll get the spectrum for 5G quickly enough that we can move on to 6G as soon as possible.
Thank you very much, Dr. Badawi. Ahmed, any thoughts?
Yeah, I think I second what Dr. Amr Badawi mentioned, is that 6G is around the corner, and we're still developing, or we're still trying to roll out 5G. And I think that we need to catch up with the world. We need to make sure that whenever the spectrum is available, we try to offer it to the operators. And we can take examples from our neighbors in the GCC, right? Like I said, WRC, they already allocated spectrum 1 year ago, and 1 year later, Saudi have already allocated the 600 megahertz, and UAE, they allocated the 600 megahertz and the upper 6 gigahertz, right? That happened all in 1 year. So the regulator plays a huge role in helping the operators do that, especially with the policies as well. We talked about the progressive policies. We need to think out of the box. If there's not enough spectrum, let's look into spectrum sharing. If we don't have, if you want to reduce the cost of rollouts, think about infrastructure sharing, right? And then also one of the things that, an example from the UAE and Saudi, what they did, because again, once the operator acquires the spectrum, they want to hit the ground running, meaning they want to deploy it right away because they spent millions, if not billions, to acquire the spectrum. So one of the things that was done was technology trials, meaning that before the spectrum was even auctioned, they allow in a controlled environment the operators to test the spectrum, right? And what happens is that the operator, they familiarize themselves with what can this spectrum offer, how can we integrate it into our policy, into our strategy, and then once they have the spectrum in their hand, they can deploy it from day one. They're not experimenting still when they have the spectrum in their hand. So again, I think that the regulators play a huge role, and I think that hopefully, we can get Egypt moving in the right direction and catch up with the rest of the world.
Thank you very much, Ahmed. Amr, final words?
So I don't want to take so much time, and I would like to thank the participant here for having us this time. So I would like to take this opportunity to thank all the participants and my colleagues here on the panel. And we are actually pleasured of being invited to such event, and we hope that such cooperation I had here did a lot of networking, a lot of discussions, a pleasure to meet my mentors always, and I would be pleased actually to have some sort of those discussions and workshops. It will leverage more, and will be towards the benefits for the whole. So thank you.
Thank you very much, Amr. Ladies and gentlemen, it wasn't a very long time ago when we were talking about introducing 5G to Africa. And at that time, I can vividly remember that one of the arguments that we kept having about 5G being introduced in Africa was the fact that we were just getting introduced to 4G and we were trying to get it rolled out. Here we are with the same conversation again about 6G. We really need to change the narrative. We need to catch up. The innovation in technology is not slowing down for us. It's not going to wait for us. The world is moving ahead. It's moving very fast. We travel out of Africa. We visit a lot of the places where these technologies are actually live. We enjoy them. We need to come back to Africa and make sure that we're implementing the right policies, the right regulation, introducing the right technology, investing correctly so that we can bring these technologies as well for the benefits of our people. Please join me in thanking our panelists for the very fantastic insights we received today. Thank you very much. Yeah. And with that, I have been given permission by my colleagues. I know it's been a very, very long day. We had a very lengthy conversation today. From us at the GSMA, we really hope that you found this session today useful. There's a lot of information that we know we crunch. We develop a lot of reports and a lot of numbers. And we really hope that we are helping you in the decision-making processes that you have to go through in your countries. I always tell my regulator friends that I never envy your jobs. You have a lot of interests to balance. You know, there's the consumers who are demanding for the services. There's government who's putting pressure on you to have to align with their agenda. There's government agencies who also have interests. There's investors from private sector who you have to balance interests for. I don't envy your jobs, but we hope that we're helping you basically to make that decision-making process proceed rapidly in your countries. So we'd like to thank our friends at the NTRA for the fantastic support we've had in making this session very possible. Our friends at EITESAL as well for helping us in delivering this session. And we bid you ma'asalam and hope you all travel back to your homes safely. Thank you very much.